Hi everyone. Now we are going to study question number 58. That's all about what is gravitational force. So the very first thing what we have to understand here is all about what is Newton gravitational law. It says there always there always an attraction force between any two masses. It doesn't matter what is the size, doesn't matter at what distance. Masses at any separation. And the range is almost up to infinity, very long distance range. So that when you consider a set of 2 point masses, fixed masses having distance r, then the gravitational force is g m1 m2 by r square, where g is 6.67 into 10 power minus 11 Newton meter square per kg square. So this is what he said, that there always an attraction force exists between every set of two masses, one big, one small, one too big or too small, whatever it is. So like that, you have to consider this formula. But this formula is mainly for 2 point masses fixed at two different positions, or two spherical bodies also you can take them like point masses. Means you have to replace them at their center of mass. You can replace a spherical body like a point mass at its center of mass, like that. Now, here, the next thing we have to understand here is when two masses are there, let's take one is m1 and another one is m2. Now, when you keep the distance, let's take d. Now, you keep another mass at a distance x. Now, this will attract. There is a force due to m1. There is a force due to m2 also, and the distance will become d minus x. Now, the resultant force on m, if it is 0, that is called null point. So, the point where resultant force is 0, that means F1 should be equal to F2. So that m1 by x square equal to m2 by d minus x whole square condition will come. Like F1 is g m1 m by x square. F2 is g m2 m into m by d minus x whole square. So m and g cancel. So this is the condition will come. Now the next thing what you have to understand here about this one is, what is the principle of superposition? See, due to system of point masses, due to system of point masses, like there is many masses are there like m1, m2 and mn, and here one mass m is there. So there are lot of forces, as many masses that many forces. Then the net force will become vector sum, algebraic sum of all the forces. So that is called principle of superposition. And to calculate this one, you need to know the resultant of two vectors. So resultant of two vectors means the formula is given by r square equal to a square plus b square plus 2ab cos theta. And when theta is 0 degrees, resultant will become a plus b. And when theta is 90 degrees, the resultant will become a square plus b square r square equal to. And when theta equal to 180 degrees, the resultant will become a minus b or b minus a, greater minus smaller. Now, when A equal to B and theta 0 means resultant is 2A or 2B, and theta 90 degrees means resultant is root 2A or root 2B, and when theta 180 degrees, the resultant is 0 if both vectors are equal, and theta 120 degrees means resultant is A or B, and theta 60 degrees means resultant is root 3A or root 3B. You have to remember all these conditions, then solving numericals will become easy. Just like one well-known example, when three equal masses are kept at three corners of equilateral triangle, and when you keep another mass at the centroid, then there are three forces acts at an angle 120, 120, 120. So that if this is the one force and the resultant of these two will become in this direction, and that is equal because all are equal, like F, F, F. Now this is also F, and the resultant of FF at 120 degrees also F. Now the resultant will become F minus F equal to 0. Like that, they may give multiple masses at the corners of square or triangle usually. So that they will ask the force due to system of masses. So then you have to use this vector addition, principle of superposition. Then only you can solve the numericals. Now, this is the simple thing, and similar kind of questions also you will get in electrostatics. Here we talk about Newton gravitational law, and here we talk about gravitational force which is due to masses. Who is responsible for this force is mass, property of mass. And relation also same, like it obeys inverse square law. It is central force. It is conservative force. Same like electrostatic force. But there electrostatic force in electrostatics, that is due to the property of charge. And there constant is K, here constant is G. But relations will come similar. There also we calculate null point. Here also we calculate null point. There also we take principle of superposition. Here also we take principle of superposition. Now comes the few examples. Let's take one simple question first. Two heavy particles of masses placed attract each other with a force. So the force equal to now G m1 m2 by r square. Now the calculate distance between them means then G m1 m2 by f. G is 6.67 into 10 power minus 11. M1 is 40. M2 is 60 whole divided by the force is, so G is only 6 into 10 power minus 11 they mentioned. So let it be as it is. And force is 4 into 10 power minus 5. So 4 tens are. Now r square equal to 6 into 10 power minus 11 into, this is 6 into 0, 0 means I can write 10 power 2. 10 power minus 5 goes up means 10 power plus 5. So 36 times, this is 7 minus 11. So 10 power minus 4. So r equal to 6 into 10 power minus 2 meter. Under root will come. So nothing but 6 centimeter. So this way you just try to take care of calculation whenever the question is based on any formula based, direct formula based. Now, if the distance between two spherical bodies, is increased to 4 times, so generally the force formula is G m1 m2 by r square. That means force is inversely proportional to square of the distance. Then how many times the mass of one of the bodies to be changed to maintain the same gravitational force? So any one mass to be changed so that the same force should be there. So let's say I will change m1. That means G is constant here, m2 is constant. Only m1 and r changing. Now the ratio, if you take f2 by f1 equal to r2 by r1 whole square into m1 by m2 whole square. This ratio you have to take such that F1 should be equal to F2. Both forces must be changed. Now, the final distance is 4 times the initial distance. That means this is 4 times, so this will become 16 times m1 by m2 whole square equal to R. You take this m1 by m2 this side, so 16 equal to m2 by m1 whole square. Then m2 by m1 will become root 16, that is nothing but 4. So m2 is 4 times m1. Oh, sorry. Here only m1 by m2 square will not come. So that square if you remove, then 16 will come. So that means mass should become 16 times. As the distance became 4 times, one of the mass should become 16 times, so that both 16 will get cancelled. Then you will get the same kind of, same amount of force even after changing distance and one of the mass. Now the next question. Two particles A and B having masses m and 4m respectively are kept at a distance. So two particles are there, m and 2m. Now they have some distance. Let's take 2.73 meter. Another small particle m is placed so that net gravitational force on it is 0. As I said, the null point concept they are asking. So this is x, means this will become r minus x. So what will be its distance from body A? A nothing but m. So I considered as x. Now we have to find x. The condition was direct condition I have given. So m by x square equal to 2m by r minus x whole square. Then mm cancel. Then 2x square equal to r minus x whole square. So root x equal to r minus x. Now x if you bring this side, root 2 plus 1 equal to r. Root 2 plus 1 into x, x you take common. So x value will become r by root 2 plus 1. So if you multiply with root 2 minus 1 and divide with root 2 minus 1, then denominator a plus b into a minus b, a square minus b square. So it will become 1. So r into root 2 minus 1. So R value they have given, root 2 is 1.414, substitute and multiply. So this way, so if you remember the formula, if you remember the conditions, whatever we have studied, then immediately after reading the question, you will realize what concept it is related to. So that immediately you can take that. That's why memorize every condition, memorize every definition, memorize every formula. Then try to understand the question quickly. Then immediately after reading the question, you will realize what to do, how to do. Now, the next thing is force between two objects of equal masses is F is 25%. Mass of one object is transferred to the other object. Then find the new force. See, force between two objects of equal masses. So both are equal masses mm. It is some distance r. So F equal to G mm by r square. Now, if 25% mass of one object is transferred to other object, then find the new force. See, now they are telling, now the situation is one mass 25% means 1/4. Now that is added to another one. Now one mass will become 3m by 4. The other one will become 5m by 4. Now the new force will become G into 3m by 4, 5m by 4 by the distance is same equal to 15 by 16 times Gm square by r square. But this is nothing but initial force. So the new force will become 15 by 16 times of initial force. So 25% mass of one object, 25% nothing but 2500 means 1/4. So 1/4 mass of one body removed, that is the condition. So you have to understand that it will become m minus m by 4. And that is transferred or given to another, added to another mass. Then it will become m plus m by 4. So that you will calculate the answer. Now one last and final question. three masses each equal to m are placed at the corners of a square. As I said, force due to multiple charges. Now three masses are there. They placed at three corners of a square now of side length a. Now calculate the force of attraction on unit mass, another mass, let's say m, but unit mass means 1 at the fourth corner. So there is one force due to this, let's take F1. There is another force due to this one, F2. But F1 equal to F2 because same masses and the same distance, that is GMM by A square. Now there is one more force due to this one. That is, let's take F3. So F3 is GMM by, the distance is equal to diagonal, that is root 2a whole square. So that F3 will become GMM by 2a square. So now F1 and F2 are perpendicular. So this is F1 and this is F2. So the resultant will be between them exactly because both are equal. And when two perpendicular vectors are there, equal vectors, then the resultant will become root 2 times one of them. So root 2 F1 or root 2 F1. So that it will become root 2 GMM by A. But already there is one more force. So that, see, there is F3 is there already and there is F1 to also came. So that the resultant force, now both vectors are in same direction. So what is the resultant will become A plus B. That's why GMM by 2A square plus, sorry, this is A square. So root 2 GMM by A square. So small m is 1 anyhow. So G capital M by A square, if you take common, 1 by 2 plus root 2. So this is the final answer. So this way you have to solve the questions based on the Newton's gravitational law. So similar kind of questions I have given as an assignment. So please try to solve all the questions, all the 5 questions, then you will get the idea about how to solve the simple questions, one of the simple concept based on the Newton gravitational law, like what is gravitational force, what is null point, and how to apply superposition principle in calculating force due to multiple masses, right? So thank you. We'll continue in the next session with the next question. Thank you all.